The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI Conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI Conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Okay, our next speaker is Peter Golter, and he's going to go over RAP document number 10, which is on leveling and reprofiling of vertical and overhead surfaces.
All right, are you starting to see a theme coming out of this? When we talk about repair, there's more than one type of repair. We're looking at spalls, joints, cracks, and overlays are the solutions to those areas as we start looking at concrete repair. So far we've addressed cracks, both epoxy and ejection, as well as gravity feed. We've looked at several repair methods as far as how do I fix the damaged, visible damaged areas. And now we're going to talk about leveling and profiling vertical and overhead instances. Why are we talking about leveling and profiling? Specifically, the applications are we're going to put a thin film on an exterior surface. What do we need to know when we talk about profiling? Well, when are we going to use it? What is the purpose of this leveling or profiling? How are we going to prepare the concrete substrate? Now that we've done isolated repair areas, now we're looking at the big field picture area. How do I select the correct material for my specific needs? What tools do I need to use? How do I apply the leveling and reprofiling materials? And of course, finally, how do we validate the installation? First, when do I use the leveling materials? Leveling materials are going to use whenever I have an unacceptable finish, either exposed to the elements or to a chemical environment, aggressive environment. Leveling materials are areas will be used on exterior or interior facades, foundations, beams, columns, and soffits, parking structures, retaining walls, jersey barriers, bridges, storage tanks, tunnels. Once we have the surface either leveled or reprofiled, then allows us to properly install or give a sound foundation for an aesthetic or protective coating. So what is that purpose? Again, provide a suitable surface, repairing the deficiencies so that we can put on a protective or aesthetic coating. Where or what constitutes deficient surfaces? Non-moving hairline cracks or plastic shrinkage cracks. These are non-full depth cracks. Shallow or small surface voids. Small honeycombs or rock pockets. Here you want to make sure an engineer validates it's just a cosmetic deficiency and not a structural deficiency. And then again, this will allow us to put on a protective aesthetic or protective surface. So how do we prep that surface? Looking at the slide on your right-hand side, take a look at the bottom of the illustration there. The surface is imperfect. It is not the greatest fallacy out there is concrete's indestructible and maintenance-free. When we deal with concrete, how was it placed? How was it consolidated? What type of forms did we use? What type of liners were in the forms? What type of release was on the forms? All questions that come up about, they need to be considered. But what we're dealing with now is the aftermath. So make sure the concrete surface is clean and properly profiled. By that we mean open porous. Make sure it's sound. Make sure all latents and bond inhibiting materials have been removed. If we talk about it in layman's terms, we want to open up that concrete and get a finish around a 60 to 100 grit sandpaper finish. How do I select the right material for my application? Well, first, what is my application? Is it going to be building facades, non-traffic bearing, non-structural surfaces? as far as seeing loads? Is it going to be curtain walls? Is it going to be beams, soffits, columns? Is it going to be bridge walls, parapets, or jersey barriers? Is it going to be tunnels, or is it going to be water, wastewater, or processing tanks? The different types of materials we could select for this application would be anything from an acrylic-based material, these are your knife and brush grade fillers, to Portland-based materials that would go and sack rub the surface, polymer modified materials, and then polymer resin, such as epoxy-based materials. The one thing we want to avoid is having high modulus, low modulus, high modulus type applications, so that I would have something soft between two higher modulus materials. What are the tools required for this installation? Again, you've seen everyone now talk about the various surface preparation methods, the tools, the power, the water, whatever's necessary for that material. Then you're going to need, for the materials themselves, a heavy-duty drill, a mixing paddle as prescribed by the manufacturer, clean buckets, emphasize the word clean on the job site. You'd be surprised what we run into sometimes. Clean tools, mortars, hawks, pools, margin trowels, finishing trowels. These also lend themselves in large applications to spray apply materials. So instead of hawking it on the wall, I can spray it on the wall and finish it that way. Now that I've selected the materials, I've got them mixed up, how do I apply them? Either spray or trowel it onto the surface, applying adequate pressure to fill the voids full of material. Finish the surface to the desired texture. What are my options? One, I can go and sponge float it. I can broom finish it. I can burlap sack it. I can also go in there and what we call a cut and shave application, filling in the pores, allowing the material to come to an initial set or final set, and then shaving the surface smooth. Now that the material is in place, it's cured out, how do I know I have a good installation? Let's go and validate it. How do we validate it? A couple test methods are available to us. Non-destructive test methods, sound it out. I love the hammer test. If it pings, it's good. If it duds, it's dead. Impact echo. These you typically see when complete systems are in place is when we're going through and validating also the coatings, the finished protective layer, to make sure that there are no surface delaminations or voids. Then, of course, destructive testing, going in there and using the direct tensile pull tests, scoring the material, passing to the substrate, gluing a disc on it, pulling it, and seeing what the mode of failure is and that we've achieved an appropriate strength. So a very simple installation, but consideration still required.